Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting topic in 8086 microprocessor. We're going to see addressing modes of 8086. Before seeing about various addressing modes, I would like to refresh the basics about addressing mode. What is addressing mode first? Right? Addressing mode tells you the different ways that a source operand can be represented in an instruction, right? How an operand can be given in different ways in an instruction, that is given by the addressing mode, right? And in general, we have immediate addressing, register addressing, direct addressing, indirect addressing, even in 8051 microcontrollers, right? So first, you will understand what is immediate, what is register, what is direct, what is indirect addressing mode, right? Immediate addressing mode is something where you will directly give the data in the instruction itself, right? So whenever we give any data directly to the instruction, that is called as immediate addressing. And what is register addressing? Whenever we use registers, right? Even the source and destination both are registers, then that particular addressing mode is called as register addressing mode, right? And very importantly, you got to know what is direct addressing, right? What from the name itself you can understand, whenever we give the address directly, that is called as direct addressing, right? That is, whenever we give the memory address directly, right? Whenever we give data directly, that is called as immediate addressing. Whenever you give address directly, that is called as direct addressing. What is indirect addressing? Instead of giving address directly, right, we can give the address through a different pointers, that is through a different registers. That is called as indirect addressing, right? So we will see all these different types of addressing in 8086, right? We have already seen different addressing modes of 8051, which is very similar here, but we have more addressing modes in 8086, right? So start with whatever I said, right? This addressing mode is different ways that the source operand can be represented in the instruction, right? And these are the different addressing modes in 8086: register addressing, immediate addressing, direct, register indirect, based addressing, indexed addressing, base index addressing, string addressing, direct IO port addressing, indirect IO port addressing, relative addressing, implied addressing, right? I want you students to go through this video very carefully, because you don't want to by heart the instructions or the addressing modes. If you understand the concept, you can write it in your own words, right? So first we'll start with the register addressing, and before that, these addressing modes in 8086 is grouped into 4 different groups. That is, group 1, that is for addressing mode of register and immediate data, right? That is register addressing and immediate addressing. Where for addressing modes of memory data, these addressing modes will be used. And for addressing the IO ports, we can use these 2 addressing. And for addressing relative addressing, we can use this addressing mode, right? And similarly, for implied addressing, where in implied addressing, we will not be having any particular operand, right? We will have only the instruction. That is, the operand will be given in the instruction itself. That is called as implied addressing. So it will be divided into 5 groups, not 4 groups. It is divided into 5 different groups. We will see one by one. First one is register addressing. As I said, whenever we use registers, right, in the instruction, you can see here move CLDH, right? This is a register and this is another register, right? Where this is an 8-bit register and this is an 8-bit register. So what is this instruction is about? This instruction will move the content of DH to the CL, right? And this instruction is called as register addressing because both source and as well as destination represents the register. We have used register. The instruction will specify the name of the register which holds the data. That is called as register addressing, right? And similarly, what is immediate addressing? As I said, immediate addressing, the data will be directly given in the instruction itself. It can be an 8-bit data or a 16-bit data. You can see here 8-bit data or 16-bit data can be specified in the instruction itself. So if you take this particular instruction, that is this particular data 08H. This is an 8-bit data. So this instruction, what it will do, move DL comma 08H. This the content, this particular data will be moved to this particular register. Right. Similarly, we can use 16-bit register, that is 16-bit data, where this is 16-bit data and we use 16-bit register here. So what is this instruction will do? It will move the 16-bit data to this particular register. Right. So that is about immediate addressing. Right. So whenever we give data directly to the instruction, that is called as immediate addressing. Right. Now we will see what is direct addressing. I have already said what is direct addressing. Instead of data, if we give the memory location directly in the instruction, you can see here this is a memory location and this is another memory location, right? So whenever this memory location is directly given, that is called as direct addressing. So what does this instruction will do? Now you can see here the square brackets. Whenever in 8086, whenever it is represented in square brackets, that represents the memory allocation, right? So this instruction, what it will do, the content which is present in this particular memory location, that will be moved to this particular register. Similarly, the content which is present in this particular location, it will be moved to this particular register, right? So this is called as direct addressing, where we have given the address directly, right? What is register indirect addressing? That is nothing but instead of giving address directly, it will be given in a register. You can see here whatever inside the bracket, that represents the address, right? So you can see here the content of this particular address, it will be, the address will be saved in this particular register, alright? So now this content will be moved here to this particular register, right? And this particular in this particular register indirect addressing, we can use all these registers BX, BP, DI and as well as SI, right? And this is about a register indirect addressing, where instead of using the address directly, we use the effective address through the register, right? And similarly, we will see what is based addressing. Base addressing, as I said here, we know that we have a base register BX, right? Here in base addressing, instead of giving the address directly, it will be given indirect, and also you will have a displacement value. What is displacement value? You can see here in register indirect addressing, you will have only the register which is holding the address, right? It will point out this register. If we go to know the address location, we have to go to this particular register, right? That is called a register indirect addressing. Whereas the base addressing, what we have to do is the 8086 microprocessor, it has to calculate the effective address. How it will calculate? It will calculate the address based upon this particular register value and as well as the given displacement value. This displacement value can be of 8-bit or 16-bit, right? You can see here in base addressing, BX or BP will be holding the base value, right? And apart from that base value, you will have a displacement value where the effective address is the combination of this base value and the displacement value, right? And you can see here when BX holds the base value, right, the effective address is calculated from BX and DX. I already said about calculating the physical address, right? So whenever we use BX, right, the effective address will be calculated from the data segment and as well as BX. And whenever we use base pointer, we can use stack register and base pointer to calculate the physical address, right? As if now you understand, base addressing is nothing but we will use base register and there will be a displacement value where the effective address is nothing but the combination of both the things, right? Only we can get the address by adding these values, right? And what is index addressing here? Index addressing is similar to base addressing, where we had base register here BX, right? Where instead of base register we will have index register. What is index register? We have SI and as well as DI, right? So the SI and DI will have the base value, right, and the displacement value will be an 8-bit or 16-bit. Similar to base addressing, you will have a SI or DI, that is indexed registers, to hold the index value, and also you will have the displacement value, right? The effective address will be calculated based upon by adding this SI and as well as this displacement value, right? So what will be the operation after calculating this address? The content in that particular address will be moved to this particular register, right? This is indexed addressing, right? And what is base index addressing? So far what we have seen is we have seen what is base addressing, right? What is index addressing, right? Now we'll see base index addressing. You know what is base addressing? What is base addressing? You will use base register and the displacement value, correct? What is index addressing? We will use index register and displacement value, right? And what is base index register? We will use base register, index register, and as well as displacement value. The combination of all these three will give the effective address, right? So the effective address has to be calculated by calculating by adding all these things, right? That is called as base index addressing. So what is this instruction will do, right? You have to calculate the address. The content of that particular location will be saved, will be transferred to this particular register, right? And it is very important that the effective address is not directly given in base addressing, index addressing, and base index addressing. It has to be effectively calculated, right? Whereas the effective address can be directly given in direct addressing. But here in the register indexing, the effective address will be given inside a register, right? And now the very important thing is string addressing. String addressing is whenever we go for string operation, right? We use this particular string addressing, right? You can see this particular instruction move byte. Whenever we use byte instruction, whenever we go for string operation, we will use this particular addressing, and the effective address will be saved in SI and DI, right? That is, the source data will be saved in SI and destination will be saved in DI. Even here the index pointers is used to save the source data and destination data, right? To understand this very clear, what this instruction will do is it will move the byte of instruction, right? Depending upon the given registers, if you have given any registers, the byte instruction will be moved to the corresponding registers. And this can be, this byte instruction can be for 8-bit or else the 16-bit word. So that it can also be like this, that is move SB and move word, which means SB is nothing but it will transfer the 8-byte, that is byte instruction, that is 1 byte, and if it is 16-bit word, then that can also be transferred using this particular string addressing, right? And next one is port IO addressing, that is direct port IO addressing and indirect port addressing. It is very similar to direct addressing and indirect addressing. If the IO port address is directly given, then that is called as direct port addressing. If the IO port address is given indirectly, then that is called as indirect IO addressing, right? You can see here in direct port addressing mode, right, the 8-bit port address is directly given in the instruction itself. You can see here, right? So now the content of this particular port, right, the content of port with this particular address, right, it will be moved to this particular register, right? So the address of the port is directly given in this particular register. Similarly, in indirect addressing, the address is not directly given, it will be given in a register. You can see here we have used DX register, which points out the 16-bit port address, right? So the content of AX is moved to this port given by this particular address, right, which is in this particular DX register. That is about direct port addressing and as well as indirect port addressing, which is very similar to direct and indirect addressing. And what is relative addressing, right? Relative addressing, even here you will have some displacement value, right? It will be an 8-bit displacement value, but here the index value, that is the base value, will be the instruction pointer, right? So this effective address will be calculated with respect to the instruction pointer. That is, you can see here JZ 0AH. This is this relative addressing where 0AH is the displacement value, where this value has to be added with the instruction pointer, which will give you the effective address. So, and after calculating that effective address, what it will do is this instruction, that is, it will jump to this particular address location. What is the address location? IP plus 0OH, right? When 0 flag is equal to 1. If it is equal to 0, then it will go to the next instruction, right? So you can see here in this addressing mode, the effective address of the program instruction is specified relative to the instruction pointer, which means this displacement value plus the instruction pointer will give you the effective address, right? So this instruction will be executed when ZF flag will be set. That is, if ZF flag is set, then it will jump to this particular address location, that is IP plus 0AH. If not, it will go to the next instruction. And the last addressing mode is implied addressing, where in implied addressing there is no specified operands, right? The operand will be in the instruction itself, right? You can see here CLC, right? CLC is nothing but clear the carry flag. Similarly, CLD, right, which will clear the destination flag, direction flag, right? So CLC is nothing but the implied instruction which will clear the carry flag, right? And similarly, CLD also is an implied instruction which will clear the direction flag, right? So here there is no operands, where only instruction is given. In the instruction itself you have the operand, that is this flags, right? So that is about different addressing modes of 8086. So today what we have seen is, we have seen different addressing modes of 8086, and we have seen every addressing mode with a specified example. I believe this video will be very useful for you. Thank you, my dear students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும் நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.